It's DH. How's it going,
Hello.
man? Hello, DH, my brother from a distant country. Lovely to see you. How are you doing, man?
Hello.
How are you doing? It's 57 years since I last saw you. What did you do for the 57 years?
I don't think it's been 57 years I haven't seen you. I don't think 57 years passed since I saw you in the last time.
Maybe 57 weeks, minutes, days, or eons. What do you think? Which one's most accurate?
Eons would be definitely not the answer. I don't think any of those are correct. But if I went to a black hole and then came back, maybe 57 eons would be correct.
Oh, well, we're going to talk a lot about black holes today because you had some great questions that you sent me some ideas for. Also, there is another possibility. It could be that you're actually dreaming right now. So the past.
But what if I was dreaming inside of dreaming? Like,
oh my goodness. Oh my goodness. A multi-dimensional dream. How far do you think you could get into a dream? How many times could you dream you're having a dream that you're having a dream that you're having a dream that you're having a dream?
I don't know. Maybe like 2,000 million times.
Oh my goodness, that sounds. I don't think we would ever have enough time to think about 2,000 million dreams inside dreams.
In an alien planet, and maybe that would be possible. Maybe, just maybe.
Oh well, we're going to talk about aliens. I've got a question about aliens too. Right, DH. My goodness, I had to really think before this interview because you sent me some ideas for questions. Not easy questions. I had to have a little think. I had to sit down like this for 10 minutes.
10 minutes?
Yeah, exactly 10. I counted myself. I counted the seconds.
How did you count? How did you count, but also thought of these by heart questions?
Oh, I just kind of partitioned my brain. So the right side of my brain became responsible for that, and the left side of my brain was counting. But I can't do two things at once. So my left side was going, wait, stop it, be quiet, hang on a minute, and it just was chaos. It was chaos. Okay. So hopefully we'll see which one was the winner. Did my right side win, so I know some answers to your questions, or did my left side win and I successfully counted 10 minutes? Who knows? Now, DH, first of all, what's your life story, DH? Tell us the big scoop on you.
So my life. So I am a boy who lives in Korea. Who lives in Korea, which is very interested in space, especially about black holes, and also obsessed in the game Minecraft in these days.
That's it? That's your story? You're a boy from Korea who likes talking about space and you love Minecraft?
Those are my main things.
Those are the main things. All right. Oh, that's pretty amazing selection of things. Because you could say like, oh, my name is DH, I'm from Korea. I enjoy mushrooms. And
I don't really like mushrooms a lot.
Oh no, hey, mushrooms are amazing. I love mushrooms. I love mushrooms. My favorite thing. I used to hate them when I was a kid, DH, and now I love them. They're great. And now I don't really eat meat. I eat mushrooms instead of meat.
Mushroom tastes great with meat. With meat together, I guess.
I respectfully disagree, DH. Now, well, we'll talk about mushrooms later because mushrooms are quite interesting, but your questions are better. Now, the first question. Now, here's what we're going to do, okay? I'm going to ask you your question and see what you think. And then we'll see if there's anything I can add to that idea, okay? Because I think it's really cool. Right, the first question you had was, how could we steal energy from a black hole? Oh my goodness, what a huge question. What do you think, man?
Okay, so this is kind of, I am the black hole teacher, and I am telling you how to survive from the dying universe guide.
Okay.
So I saw it in one video. I know it very well. So if we want to know how to steal energy from black hole, we need to know about black holes. So black holes are very strange. They are made when very massive, humongous stars explode explode, and yeah, it just becomes a black hole. Black hole just absorbs anything. So black holes are very strange, and not black holes. There is a line that if you go inside it, you can't come out. You have to move faster than light, which is impossible.
What's the name of that line? Do you know the name?
Huh?
Do you know the name of that line?
It's called Event Horizon.
Yeah, it sounds really beautiful, right? Yeah. Actually, it's terrifying. Yeah. But yeah, okay, the event horizon. So if you cross the event horizon... I
don't want to go inside that.
Well, there is a way to escape, possibly, theoretically. Who knows? We're going to talk about that a bit later, but there might be a way. Okay, right, so keep going, man. So black hole is this incredibly dense thing in space that is black, which you can explain as well why it's black. If you cross the event horizon, you get sucked in and cannot escape. Okay, why?
Light can't escape, so it's black. So so our rules of the universe. So if a star is rotating, if a star is rotating, and if we have the same mass and then just gets smaller and smaller and smaller and smaller, it spins way faster. So black holes are still spinning, like some black holes billion times a second around. But black holes are dense, so they kind of warp space with it. It kind of become like curves. So if something enters it, if we go the way the black hole spins, we can be incredibly fast. So this is our main idea. It's very strange.
Okay, so we have this kind of concept that a black hole is essentially something that has massive amounts of gravity, like a star, like a planet, like a moon. So you can use the gravity to slingshot around, like spaceships do. When they go to the moon, you can go around the moon and use the moon's gravity to get I think it's called a moon gravity assist in space. Okay, so theoretically, you could stay outside the event horizon really fast and kind of orbit the black hole, which is kind of what the galaxy is doing, right? Because there are at the center of galaxies, you often find a giant black hole. The galaxy is orbiting the black hole, the supermassive black holes, which is cool, right? Okay. So we've got this idea of a black hole. Now, I wanted to ask you the next question because there's some really interesting stuff we can get into that. We talked about the event horizon, right? Now, your next question was about black holes, was what if you had a nickel-sized black hole inside your pocket?
So this is a really cool answer. Short answer, you instantly die. So if it had a mass of a coin, you would die very quickly. Firstly, we need to know how black holes actually die, because black holes die because of something fancy science word called Hawking radiation. So the concept of Hawking radiation, that empty space is not empty space.
I'm just going to draw a black hole while you're speaking so we can think about it.
empty space is not an empty space. So it's not an empty space, but in a blink of a second, two particle and an antiparticle is born, and then just bloop, and then just annihilating each other again. So if this happens on the event horizon, I told, one goes inside the black hole, one just escapes. Event horizon is the part of a black hole, so the black hole is losing energy. After eons and eons have passed, it will eventually die because of, and just radiate away. So yeah, very cool. And then so our nickel has our black hole has the mass of a nickel, so it's very, very, very small. So it's if I write it, it's that, which is very confusing. A hydrogen atom is that. So it's like comparing this mini black hole as this hydrogen atom is comparing a hydrogen atom against the sun.
Okay, so just to kind of clarify, you were saying that a tiny black hole is actually more powerful than a supergiant black hole. Is there a difference in strength?
If it's more massive, the gravitational pull will be very massive, but this one will radiate away very quickly because of this strange thing called Hawking radiation.
So a tiny black hole.
It will explode bigger than the Hiroshima explosion.
So there is more Hawking's radiation escaping. Did you ever read about the tidal effects of a tiny black hole?
No. And there are tidal effects of the moon, but not a black hole.
Well, similar idea, right? So when you're thinking about space, you're thinking about the tidal effects. The tidal effects of the moon move the oceans on the Earth. So it's incredibly powerful. It's just essentially gravity, right? But the idea is that a tiny nickel-sized black hole would have greater tidal effects than a normal-sized black hole. So it would affect things more quickly, in a sense. So you talked about being spaghettified, right? So if you get closer to a tiny black hole, you would be spaghettified far faster. If you go close to a larger black hole, like you said, you would have some chance to kind of just stay on one side of the event horizon, but the tiny black hole would have a much faster reaction, and you would be pulled in much faster. Of course, we wouldn't be able to see it because we would just continue, right? And you would be frozen in space forever outside the black hole. But I just think it's quite fascinating. It's quite fascinating. So if you ever go to school with a tiny black hole in your pocket, you're dooming everybody on the planet, man.
Yeah.
Don't do it.
And also giant tsunamis for everyone. Wow, disastrous.
Oh, why? Can you explain? Why would there be tsunamis?
Because like the moon is, well, tidal wave. The moon is causing the moon. The tidal force is not that strong for moons, but black holes are extreme. just extreme.
Mhm.
They have so much gravitational pulls, even in a short second, they will just giant almost the whole ocean would be pulled to you, and then you just be fling away and like that.
Well, also though, you've got to remember as well that a black hole is so powerful it's going to tear atoms apart into atom to atom to atom to atom, a string of atoms. So you've also got to think about this, the ocean. So the ocean is going to be pulled towards you, but then also think about this, not just water will be pulled towards you. Every atom on the planet will start to swirl around you. It will be ripped apart. So instead of thinking like there's going to be a tsunami of water that comes towards you, there's going to be a tsunami of all matter on Earth that will start
that will be terrible.
swirling around you like some sort of cloud of dust.
I should not make a tiny black hole.
Yeah, please don't do it.
And also, you would get ripped apart by cell to cell to cell, and then atom to atom to atom, and die. Of course, I said in the short answer, we die.
Yeah, you die really quickly. That would be the short answer. The long answer is you would die really quickly with lots of complex science.
Yeah.
But actually, we're going to talk about cells a little bit later. But there was one more question I wanted to ask you about that, actually, because there was another really interesting thing. Oh yeah, about how black holes die. So you kind of talked about that, right? Because you said with Hawking's radiation, it will basically leak energy back into the atmosphere. That actually connects to two other things you were thinking about why do we think, or why do we imagine? And then the other thing was talking about fusion energy. Because if we talk about fusion, we're talking about radiation. What is radiation? When somebody says radiation, what are they talking about?
There are a lot of words called radiation. The radiation, if you get too close, you die. We use radiation in X-rays. Anyways, it's some sort of energy that's energy that something kind of, for example, an uranium atom just shoots out X-rays and gamma rays. Those are radiation. So these are just energy. So radiation, I believe there are three sorts of radiation. It is very simple. Alpha, beta, and gamma. The most powerful one is gamma. Don't be close to something that just sprays out gamma rays.
Well, here's a question. Alpha, beta, and gamma. So, okay, how can I protect myself from alpha radiation?
Alpha radiation, it can't even go through a paper.
Absolutely, right? A piece of paper. How about beta radiation?
A little bit of aluminum.
Yeah, a bit of metal, right? How about gamma radiation?
Lead or more than 1 meter of concrete.
Oh no. So you're gonna construct a lead suit to walk around.
But the problem is lead, it has some sort of a little bit of, it's kind of poisonous, but it has a super ability that protects radiation.
Well, here's something interesting about radiation. If you know, when you fly to another country, you get on an airplane, right?
Yeah.
What researchers have found is that the people who are working on planes, like pilots and flight attendants, have a lot more cancer in their life. Why do you think that is?
I think that the sun is making fusion energy inside and just spraying out, just sprinkling out energy and light and heat and also radiation.
Mm, mm,
So if you are higher up,
mm.
The atmosphere doesn't protect you as much as you're in the ground.
Mm.
So you get more sunlight, then more radiation. Radiation makes your cells mutate, and then we get cancer. Oh no!
Absolutely. Oh my goodness, I couldn't have put it better myself, man. Absolutely. So the
Maybe
risk.
I don't want to be a pilot.
Oh yeah, no. When I found that out, I think I wrote it in one of the books that maybe you studied. I think I wrote about that. But the moment I figured that out, I was, oh my goodness. Well, also, but this is where evolution comes into it, because you can see I've got little moles on my arm, which is basically a mutation caused by radiation from the sun. I wasn't born with these moles, but my skin has reacted to the energy radiating from the sun, which is why you've got to be very careful, depending on what latitude you live on or where you come from, that your skin can be better in some places. So I can't go and live somewhere really, really sunny, because my skin is as weak as a tiny kitten when it's in the sunlight. But other people may have more protection.
That's why we have very powerful sun cream.
Absolutely. I highly recommend this factor 50 sunscreen right here. I'll send some to you, DH, and you can have some. Right. Okay. So we're talking about radiation. Radiation is energy moving. You were talking about this alpha, beta, gamma, right? Well, let's get into this idea of energy from fusion reactions or fusion energy. What is that? How do you think it's going to work?
So is simply saying it's hitting nucleuses really, really hard and fusioning new atoms.
Oh, so how does that work? So how can you open an atom?
No. So we have to make it really, 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 really hot, like inside the sun, of course. And then if it's really, really hot, electrons just fly away, and then nucleuses just move around, but the temperature is too hot and the atoms are moving too fast. So the protons can't repel each other. So they fuse new atoms and give off energy.
Yeah, I always think of a great analogy for fusion reactions is the idea of an egg. That if you put one egg down, like a chicken egg right here, you put a chicken egg or an ostrich egg, which is gigantic, which is really great. I would love to throw an ostrich egg. No, I wouldn't, because I could harm a poor ostrich. But anyway, let's imagine, right? So you have an ostrich egg, and then you take another ostrich egg. Well, first of all, you got to get it the right way. A chicken egg, if it's like this, you can stand on top of it. It's incredibly strong. If you put it like this, it cracks easily, right? So if you take a chicken egg or an ostrich egg and you put it on the side and you drop another egg on top of it, what happens to the egg at the bottom?
Cracks.
It cracks, right? When it cracks, it releases energy. So that's your atom. If you think of the atom being your chicken egg, it opens. When it opens, it releases energy or a yolk. Now imagine that yolk is energy, and then that hits another egg, breaks it open. Hits another egg, breaks it open, and it continues to happen, like you said, right? It's like chicken eggs smashing each other, and it never stops. What's the problem with it? With breaking open these atoms to get the energy that spills out?
So technically, the chicken eggs sound like similar to nuclear fission, which is just hitting an atom with a neutron and then splitting it, bam, into two stuff.
To fissure, to create a crack and break open, right?
Yeah. and the yolk is the energy, and then those yolks break other eggs, which doesn't make sense, but let's say.
Yes.
Yeah.
And then you get into fusion, where these atoms, the protons, start to bond to other atoms, but it's too fast, so it keeps bonding and breaking and bonding and breaking, and you get this incredible energy, which is kind of perpetual almost. It can kind of go on forever. But what's the problem with it? So if I decide, oh, I'm going to put a fusion energy battery in my phone, what's the problem?
Okay, so firstly, you have to make your phone very, very, very hot, because I mentioned that two protons to bond, it has to be very, very hot, and then to not repel each other. So you're if you just get just a little close to your phone, you will burn to death.
Oh,
like
no.
Lava.
Oh no, keep that thing away from me. All right, okay. So let's
it
imagine.
would be not the best idea to put fusion energy in your phone.
Let's imagine though that I had some heat-proof gloves, so I could hold it, and I'm not going to burn to death. What's a long-term problem of having a fusion energy phone next to me?
It needs fuel, and then the fuel, or there are two fuel. That firstly is deuterium, which is a fancy science word for heavier hydrogen, and then tritium, which is the main problem, and tritium is the most heavy hydrogen, and is radioactive.
Oh my goodness.
And it's incredibly rare on Earth, but we can use helium-3, which is another sort of heavier helium. And
quick question: how can it be heavier than another kind of helium or another kind of element?
So atoms are made of protons, neutrons, and electrons. If we have more neutrons, it becomes heavier. But the proton number and the electron number is the same, so it's stable.
Okay, so the more, if we can count almost mass or density, the more of a thing that you have, the heavier it is, right? The more cells you have, the heavier you are, or the more like flesh you have. Similar to weighing humans, right? Weighing an atom, put a little atom on the scale. How much do you weigh? Okay, cool. Okay, so where were we? What were we talking about? I'm now thinking about putting atoms on a scale now.
So the fuel,
or
deuterium, which is definitely not rare, we can find it everywhere. And then tritium, which is radioactive, so we don't want to use it. So if we find another one called helium-3, we can use that for fusion fuel. It is still better than tritium, which is absolutely radioactive and kill you.
Oh, so we get to the idea of radioactivity and radiation poisoning, which would eventually, what would happen to you? How would it kill you? Would this happen in 24 hours because of exposure, or would it take 20 years? What kind of painful future are we talking about here?
The radiation will rip your DNA apart and make cancer.
Oh no!
Not the best idea to put radioactive stuff in your phone.
Absolutely. Well, did you know that years and years and years and years ago, when they first, I forget which element it was, possibly plutonium. No, it wasn't plutonium. I think it was something else. Uranium, possibly. They made toothpaste. From uranium, they made you.
What is was it radium or
Oh, possibly radium. Yeah, I think you're right. And they made toothpaste. So people's teeth used to glow in the dark at night because it was radioactive. But eventually, from this toothpaste, people's teeth started to fall out. So it wasn't a very successful or popular toothpaste after people's teeth started falling out. Now, DH, here's the next question. Okay, we're talking about fusion energy, right? And terrible idea. Don't have a fusion energy battery in your phone because you'll kill everybody around you, including yourself. Well, I wanted to link this. You talked about elements. We're talking about atoms. We're talking about elements. We're talking about molecules. We're talking about cells. Here's a question. Okay, an atom is inanimate, right? So this book is made of cells. Oh, sorry, it's made of atoms, and it's inanimate. It's not living. You are made of atoms, but you are animate. You are alive. How is there a difference? How can there be a difference between an inanimate bunch or blob of atoms and an animate blob of atoms like you and me?
So maybe we can say, like, we are made of different atoms in such luck, and then we became new, sort of that. Paper is. They really don't need energy. They're not living, but we use energy and everything. So, well, our ancestor was these tiny bacteria. Absolutely. Yeah, I guess bacteria.
Well, but also think about, remember that a book is made of paper. A paper was a tree, and a tree is living. It is animate. So we've got to think about this question. So what is a tree made of?
Tree made of, I don't know, some molecules, which is made of atoms.
Oh, well, let's think about the element. Which element do you think dominates all life on Earth?
Okay, most importantly, carbon.
Yes.
I think so.
Carbon, absolutely. Now, okay, now here's another question. If you took all of the most common elements in space, in the universe, and the most common elements in life on Earth, what do you think they are?
The most common elements in the universe, I think, hydrogen, and then hydrogen. The most common atoms in our body are firstly, of course, carbon, and then oxygen, hydrogen. Those two.
Almost. In the universe, hydrogen. In our bodies, hydrogen. Number two, in the universe, almost. In the universe, oxygen. In our bodies, oxygen. In the universe, number three is carbon. In our bodies, carbon. Our molecules, our bodies are made of exactly the same stuff in the universe. And carbon is really special because carbon is the only one of them that you can make things with. It's incredibly active. I think in physics, they talk about the idea that carbon is, well, chemistry, physics, they talk about the idea that carbon is incredibly fertile, that you can do so many things with fertile, but you can barely do anything with hydrogen.
I have one thing that makes carbon extreme. So if the electrons in the outer layer of the atom chooses how it will work. For example, sodium, if we throw it in water, it explodes, it becomes a bomb, we die. But carbon, if it's full, it has 8 electrons. But if a carbon has exactly the half 4 electrons, in the most outer layer.
Mm-hmm.
So it has, maybe we can say, arms that can grab to other atoms. It has the most one. And it's very stable because it has exactly the half.
So it can kind of join with other things. It can find and migrate. It's like a chimpanzee in a tree, right? If it has no arms and legs, it can't eat very much. It can't move. It can't evolve. But the moment it has arms,
one arm.
So okay, so it's almost like the evolution of elements. Some elements have evolved to be better at changing. So now we had this question. You asked a question about how or why do we imagine? What do you think about that?
Yeah.
Now I'm linking this from, we just talked about elements and molecules and atoms. So now how do you think that links? Why do you think we imagine things?
So I think the reason why we imagine is because we had hard lives as cavemen. Cavemen surviving. We imagined of happier lives, and then starting to imagine stuff that helps us to survive better, and then we began to make theories and then discovering things.
So you're kind of saying that to imagine something is to think about something, or is there a difference?
Imagine something is that if we don't know something, but we think that is real, and then just our minds are not thinking about something real, something not real, but thinking is something we think, we go deeper in something we know. I think so.
Well, you've got all these different kinds of thinking, right? You've got to review is to think about something again. To reflect is to reconsider something that happened. You have to hypothesize, to think about something you don't know, but to think about an idea why maybe it is like this, like a theory, right? So a theory about something is an unproved or unproven idea.
Yeah.
So there are all kinds of thinking. Well, I had a question though. Biologically, how do we think? So this is where we get to think about you, DH, and James teacher. So I'm made of mass, right? Matter. I am stuff, and that matter is made of atoms at the smallest scale, and then subatomically it's made of other things as well, right? So, and again, we talked about something is non-living, inanimate, and something is living and animate. So now, how about inside my head right now, I can think, but that's only possible because my brain is made of individual cells, which are made of distinct atoms. How can all of these cells, which are separate, create me or create you? That person who lives inside your head, that's you. How can all those things work together to make that? What do you think?
It's also really strange that if we just take our brain and then just splash it in my table, is not living. But if we just put it inside our head, I'm living. So these cells kind of teamwork, I don't know, and then send signals to each other, which surprisingly is electricity, not that kind of electricity we use in our computer or smartphones.
Oh, well, hang on. What's the difference between the electricity inside our body compared to electricity helping us talk to each other right now?
Well, it is the same, but the power is sort of weaker.
Yeah, there we go. So it's all electrons, right? Electrons are moving. Actually, in fact, the video I see of you right now is basically just electrons on a screen moving about. TVs are made of electrons firing across the screen. So I'm looking at a giant electron that looks like DH.
Giant electron looks like me. And I'm looking at giant electron that looks like James' teacher.
Absolutely. Okay, right. So I keep taking you onto a different subject, right? So okay, electrons. So your brain has electrons and electrical impulses firing around. And you think they work together? Do they kind of whisper to each other? Pew, like that? Pew, 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 pew.
Yeah, they kind of do like that. And then one sends a electric signal, blah, blah, blah. And then that like chain reaction, and then just fires 2 electrons to other things, and those teamwork together and make a make our mom arms move and
Absolutely.
my mouth move.
Well, you know this. I'm pretty sure you know this. How does your arm move? Here's my muscle right here. This is the triceps muscle right here. How can I make my arm, this muscle does that? How does it work? From my brain to here, how does it work?
So it sends a signal to here, and then an electric signal to here, here, and then if this thing gets a electric signal, it kind of like,
what's the word? Contracts.
Oh yeah, contract. So it contracts our muscles, and then we can move our arms.
Well, where does the energy for the muscle to move come from?
The food we eat. So that food comes from the sun. Okay,
so we use sunlight and electricity. And how about oxygen? Where does oxygen come into this? Why do we need that?
Huh?
Why do we need oxygen?
We need oxygen. I think we need oxygen for different chemical reactions for molecules and stuff that make our body or all our hormones and our brain work, everything.
Absolutely. Well, think about oxygen in terms of muscles, in terms of movement. It's just like nuclear fission, because basically oxygen is the thing that opens the energy from food, from calories, and then we take the energy out of the food, use that in a chemical reaction to contract our muscles, which is why if you keep doing this and you stop breathing, eventually you start to get like a burning sensation in your muscle, because your muscle doesn't have enough oxygen to open more energy to keep contracting. And eventually you just go, and you can't do anything. So you need oxygen. That's why you breathe. And your brain uses 20% of your energy. So oxygen goes to your brain, opens it up, opens up the energy, and then you can actually think. Oh my goodness. Oh, I'm going to be dreaming about some of these ideas tonight. This is fantastic. Right now, I've got, DH, I think I've got one more question for you. Okay, I've got one more question. But you can pick the question you want to talk about. All right, I'm going to read some of the questions we have left, and you can tell me which one. Okay, let me see. Do you think that aliens are a feasible concept, and do you think they could visit Earth? That's the first question. The next question is, how do skyhooks work?
I like that.
Interesting question. And of course, don't worry, I didn't forget about Minecraft. I've got a bonus question about Minecraft for you, okay? But what do you think? So skyhooks, or the other one, which was, do you think the aliens could feasibly visit Earth? And do you think they are a feasible concept?
Maybe. I want to tell you about the really strange but very fun concept of skyhooks.
Hang on a minute, did you say the word fun? I think you said the word fun. Did you really say the word fun?
The marvelous concept of skyhooks.
Oh, the marvelous, fascinating, thrilling, exhilarating concept of skyhooks. Okay, great. Let's pretend I never heard the word fun. All right. Okay, go ahead. Tell me about sky. What do you know about skyhooks?
So skyhooks make space traveling a lot easier and efficient. So if we send rockets, we can't reuse them a lot. We can't. It's too inefficient. It takes too much energy to just launch rockets into space only with their fuel. A tiny amount of payload and a ton of mostly fuel tanks.
Oh, what usually, because there's a big difference, right? So an airplane uses mostly what kind of energy source or fuel, I should say?
It uses, well, airplanes are fairly much slower, like a Usain Bolt and an ant or a turtle.
Well, I'm glad you didn't say cockroaches, because actually, if you had a Usain Bolt-sized cockroach, it would be able to probably run at the same speed as an airplane, because it has incredibly amazing physical gifts. Okay, so an airplane uses oil, right? That's its main source of fuel. But how about a rocket or a shuttle that is taking off from Earth?
So it's liquid hydrogen and oxygen, which burns really quickly and just like some sort of explodes, and then it just flies away at the speed of 4,000 kilometers per hour. I heard of.
And remember the oxygen. Remember the oxygen helps to open the energy in our muscles to use on the space rocket. The oxygen helps to open the hydrogen, so it burns hotter and more efficiently. All right, so so you got that. Yeah, sounds really complicated, right? And so expensive, incredibly expensive. Gravity is just the worst. It's the worst. It's the reason why old people are bending over, because their bones are being slowly pulled down to the earth by gravity. So unforgiving. So so the skyhook. Why would a skyhook be better than the idea of a space shuttle or rocket?
So the idea of a skyhook, a very heavy counterweight is in one side, a very long and thin rope is on the other side. It's spinning and also orbiting around Earth. What if we catch the end long side and then it spins and then flings away like a swing, and then we can go much further.
So how about this thing that you're going to put, that you want to take to space? Can it just pick it up off the ground?
No, if that spins almost on the surface, the rope will burn, and then it will fall down to the ground and smash into billion pieces.
Yeah, and also this object that you put on the rope is going to start smashing against everything else.
Oh no!
It's going to be like a tsunami running like through, like a wrecking ball through cities. All right, so you can put stuff in space. Okay, cool. Why don't we do it? Why haven't we done it yet?
I don't know. Maybe we have other things to concentrate on, or we don't still have the technology to make it, maybe no investments a lot.
That's a really intelligent idea. What do you think? Investments? Why do you think there's been no investment in the idea yet?
Rich people are thinking we have to focus on the main problem and the most popular idea that will work well. And then if they invest money, they get more money. So
yeah.
they want to earn money. But they think Skyhook is not that we can't believe in that it will work for a long time. So they don't want to invest money on Skyhooks.
Absolutely. It's like Samsung. Why does Samsung not make Skyhooks? They make phones because you make more profit from making a phone. Yeah. Here's another idea, DH, that's quite interesting. Light bulbs. We use light bulbs. Yeah. Did you know, I can't remember how many years ago, but an everlasting, unbreakable light bulb was invented 60, 70 years ago. What? So you could buy one light bulb, stick it in the light, and it would never burn out. What? But all of the light bulb companies got together and said, this is terrible. Because if we sell one light bulb and it lasts for 50 years, we can't sell any more.
We can't sell more.
So they all met together and they agreed to make all light bulbs burn out after a certain number of days or months.
Oh.
So that there would be more customers to buy more light bulbs. Isn't that terrible? The idea of a Skyhook is really interesting because when I was a kid, my grandfather used to do this thing where I was really tiny and he used to grab my hands and he used to spin in a circle, just right like this, right? Yeah. And then I used to be on the end of his arms and I would be spinning around. And it's basically the idea of a Skyhook, because the Skyhook, my grandfather was generating centripetal force that would pull me in toward him, like a kind of like a spinning object, right? Like something in space. Yeah. So you've got to, maybe we should call the first Skyhook the grandfather spinner. And that would be the name of this thing.
I like the name.
Spinning kids. You should try with your mom later. Say, Mom, I want to generate some centripetal force. Hang on. And then you got to spin her around the living room, okay? And let's see if she says yes. Now, one more question. Maybe it's your favorite topic of all. It's about Minecraft. And I wanted to ask you specifically, what do you think are the benefits for children of playing Minecraft? Because some people say, oh, it's a game. No, games for children. That doesn't help them learn. They should be taking tests. Why does Minecraft help?
Minecraft kind of improves the imagination of kids. I say because we can do anything in Minecraft, except it's very squarish. We can build anything. We can build anything in our imagination. We can do everything. Also, Minecraft has an education edition, which helps kids educate.
Okay. So do you think that we should basically get every single kid in the world to play Minecraft?
If they just blow up dynamite and then just explode everything, it will not be helpful. But if that is disabled in the game, it would be okay. It will be actually excellent. It will be a marvelous, fascinating, amazing game that will help all childs get educated.
Well, DH, I think you've also discovered the secret to peace on Earth and a happy humanity. You have to disable dynamite. Get rid of all weapons and guns and knives and weapons, and then you can do everything. Same for Minecraft. Or maybe I should play. Have you seen, there's a great website I found, brilliant.org. Have you seen that?
Oh, yeah, I've heard of it a lot.
Have you tried it? It's really cool. It's really, really cool.
Well, I haven't tried it, but Mom says it will be cool to test it out when I'm a little older.
Oh, absolutely. Well, when you do, let me know. When she says a little bit older, does she mean like 30 minutes older, or does she mean like 30 years older, or 3,000 years older?
Maybe I am 10. I am 11 and currently in Korean age. So maybe about 3 or 4 years later, or even 2.
Oh, yeah. I think you could do it in a year. I think you could handle that. Your vast intelligence is ready for the world, DH. Now, DH, final question. Do you have any questions for me? Anything you want to know? But please don't test me. I just don't want to not know the answer and then go, I don't know the answer. Any question you want, DH? I'll try. I'll be bold. I'll be brave.
How did you plan and thought about Jool education in the first place?
Oh my goodness. Oh, that's a great question to ask me. So Jool education. It started with people like you, man, because I saw how incredible you were when I used to teach you, didn't I, in first grade? And I thought, oh my goodness, these kids are amazing. They can do anything. But I thought there's a bit too much stress and too many tests. And sometimes these tests I didn't think were really helping kids. So I thought, okay, so if you take that away, but then get rid of all of the boring stuff. I know sometimes it can be boring. I try my best, but sometimes it can be boring. But take away as much of the boring stuff as you can and replace all of that with amazing questions about black holes and space and all that kind of stuff. And then I think maybe kids are going to start to love and enjoy it instead of thinking, oh no, I didn't study for my vocabulary test. They're going to be thinking, I've got this amazing idea to invent something to change the world. Exactly. That's exactly what I thought. Yeah. And I did that when I said, invent something to change the world. That's what I did. So no, so why, how did I think about the idea for Jool? I've got to say thank you to you. You and like the kids I taught inspired me because you're amazing. There you go.
Thank you.
You're going to say, oh my goodness, James teaches this. Oh, I'm blushing. But yeah, no, it's because of you, man. You should be proud. I'm going to stick a big picture of your face as the Jool logo and say Jool with DH. And that's what we'll do, okay? Now, oh my goodness, I had a great time.